Okay, let me do this one. This one's got a slightly different pattern than the other ones, right? Instead of telling us the speed of the waves in the pipe, we just know the fundamental frequency, right? This is, by the way, very close to middle C, or it is middle C, I can't remember. And so it is a one end open, one end fixed pipe. Ooh, this is the trickiest one of all. Okay, so let's do this. Let's draw our little pipes. There's one, let's go. Hope you appreciate these straight lines I'm able to draw. No skill whatsoever is required. Okay, some skill. I can't sell myself that short. Okay. There's a fundamental. Here's the second harmonic, sorry. First overtone, second harmonic. And this guy is a fifth, and then split that. It's like. Okay, I want you to try this. You're laughing at me, but don't laugh at me. It's me. Okay. And we know that this is 256 hertz. Okay. So let's do a calculation here, right? We also know that this pipe is 0.318 meters long. Okay. So let's figure out the wavelength just for fun. Okay. We already know the frequency, right? The frequency is 256, right? Okay. But we got to figure out the wavelength. So let's do that. So this is 1/4 wavelength. So we go 0.318 is 1/4 of the wavelength. Okay. And so we're going to find the wavelength. 0.318 times 4 is 1.272. Okay. And then, now we got that answer, right? So here we have both answers, right? What's the frequency? Well, notice I'm telling you the frequency of the fundamental. So one of the answers that I ask you for, I also tell you. Some people find that confusing. And then I just figured out the wavelength there, right? Now for the next one, we know that this is 0.318. So let's figure out the wavelengths, right? That's 3/4 wavelengths. So we go 0.318 is 3/4 wavelengths. So now we can do maths. 0.318 times 4 divided by 3. And get 0.424. Okay. So I now have the second harmonic's wavelength, but how do I get its frequency? Well, there are two ways. Way number one is that this frequency, the pattern here for this pipe is 1F0, 3F0, 5F0. So way number one is to just take that and multiply by 3. So 3 times 256 is 768, right? This will be 768 hertz. Okay. And then this will be 5 times that. So let's go 5 times 256, 1280. Now let's suppose you forgot that. We did this. You might have fallen asleep in class when we did that. It's hard to stay awake. Lunch starts to kick in, or lack of lunch, or I don't know, staying up all night watching Orange is the New Black, and it's hard to pay attention, right? So one way to do this is, obviously we haven't figured out the speed yet, right? In all the other ones, we use this formula, V is F lambda, to find the frequency, right? But we don't know the wave speed here. But can't we calculate it? We've got the frequency there, and we've got the lambda there. So let's do it. Okay, so the frequency is, or the velocity is, frequency times wavelength, so it's 256 times 1.272. 256 times 1, don't round, 1.272. 325.632. Ta-da! That's our newly calculated wave speed on here. So let's suppose you just forget. You're like, gee, I can't remember. One end fixed. It's easy, right? The The ones that are symmetrical, both ends open, both ends closed, are just 1, 2, 3, 4, 5, 6, 7, and so on. This one is the weird one, right? It's 1, 3, 5, 7, 9, all the odd multiples, right? Let's suppose if you forget that though, just find the velocity, find the wave speed, and then just use v as f lambda, right? So 325.632 is 0.424 times the frequency, right? So this is v is lambda f, right? I just moved it around a little bit, right? So I just take that guy, divide by 0.424, and I get 768 exactly, which is kind of a hard way to do it, but if you forget, you should be punished for forgetting. All right. Oh, we haven't even figured out this wavelength. Let's do it. All right, here we go. Let's do 1, 2, 3, 4, 5. Is that right? 5 quarter wavelengths. So 0.318 is 5 quarter wavelengths, right? So now let's find the wavelength. The wavelength is 0.318 times 4 divided by 5. 0.2544. All right, so now let's just figure out our frequency using the same wave speed. These will all have the same wave speed, right? 325. Because remember, wave speed does not depend on wavelength, frequency, amplitude. Depends on what kind of medium it is, and that's not different. Okay, so let's go 0.2544 times the frequency. I'm using v as f lambda, only I'm writing it v as lambda f. All right, so 325.632 divided by is exactly 1280. Okay, so figuring out on these problems where I tell you the frequency, figuring out the other frequencies is as simple as remembering what the pattern is and either multiplying, which is what I would do. Okay, if you forget, you can always find it by finding the wave speed, which incidentally on these ones, I'll ask you for the wave speed later on in the problem. So you got to find it somehow, right? Use the wave speed, and it's the same wave speed for all of these guys because it's the same medium. Okay, and then you can use the wave speed to find the frequency if you want.